Hi, welcome. Today we can study how we can get convergence and divergence. How we can have one example like 2 over square root x square plus 3. Then how we can get limit this function? Then this function equal while we get limit x go infinity for 2 square root x square plus 3, that equal limit x go to infinity for 2, we can get square root under square outside, then get x square root 1 plus 3 over x square, that equal while we replace x 3 over 3 x square, that equal 3 over infinity equal 0 and square root 1 and this infinity, then that equal limit x go to infinity to over x, that equal 2 over infinity, that equal 0. Then we can say the sequence of converges at 0. Then the sequence converges equal 0. Okay, we can have another example. X minus 3 factorial x minus 1 factorial. Then how we can get in limit? Then limit x minus 3 over x minus 1 factorial x go to infinity, that equal we can solve this. It will limit equal limit for x minus 3 factorial, and we can get to n minus 1 multiply n minus 2 for x minus 3 factorial. This go with this, then equal limit 1 over x minus 1 multiply x minus 2, then equal also this x go to infinity, then equal 0, then also the sequence convergence equal 0. We have another example, number 3. How we can get 1 plus minus 1 power x over x. How we can get limit for this? We know already limit minus 1 for the sequence over n, it equal 0. Then that get limit for x go to infinity for 1 plus 0, then equal 1. The sequence convergence equal 1. Number 4, how we can solve this? X plus 1 over n. Then how we can get limit? Then limit x go to infinity for square root x plus 1 over n. We can make this equal limit x, then 1 plus 1 over x, then that equal the x go outside square root, then square root x, this limit square root for 1 plus 1 over x over x, that means x square root x multiply square root x, then this go, then that equal limit for square root 1 plus 1 over x over square root x, then that equal 0. Then the sequence converges and its limit equal 0. Okay, we can have another example. Number 5, n power over n. This the sequence. How we can get limit? We can put y equal this power n over 1 over n, n 1 n. Then we can get ln y equal 1 over n ln n. Then we can that mean ln n over n. Now we can need this limit. Then we can get limit for n go to infinity for ln y equal limit for n go to multiply for ln n over n, that equal limit n go to infinity for that meaning ln y mean 1 over n over 1, then that get limit n go to infinity for 1 over n, then that equal 1 over infinity, then equal 0. Then not this limit but this what? This ln y equal 0, then n go to y, then ln n go to infinity for e ln y equal e 0 equal 1. Then we find limit n go to infinity for y then equal 1. That means the sequence converges equal 1. Okay, another question, number 6, 2 power n over 2n factorial. How we can get limit for sequence? Then we can solve this power and we can solve factorial. That means we know already 2n that equal 2 multiply 2n minus 1, like that. Then we can use this idea to solve this equation and this sequence. Then while we say 2 equal 4, that means 2 multiply 2 3. Then we can solve and replace like that. We can solve this the same idea. Then we can get the limit for n go to infinity for 2 power n over 2n factorial. We can solve this and we can use some idea. We put a n equal 2n power 2n factorial. That means a n power plus 1 that equal 2n power 1 over 2n plus 1 factorial. That means 2n plus 1 over 2n plus 2 factorial. Then we can say an plus 1 over an equal 2n plus 1 over 2n plus 2 factorial. That means we can divide for a 2 power n over 2n factorial. Then that means, and we replace multiply, that means then a n plus 1 over a n that equal 2 over 2n plus 2 multiply 2n plus 1 multiply 2n factorial. Okay, multiply 2n over 1. Then that equal 2n plus 2 multiply 2n plus 1. Then an plus 1 over an that equal 1 over n plus 1 to n plus 1. We can solve, take this outside. Then we can get limit for n go to infinity. Then a n plus 1 over a n that equal 0. 0 less than 1. Then the sequence for answer that equal 0. Okay. Okay, we can solve another example in another video. Thank you so much, and with you Mr. Saleh.